The topic is understanding the working and operation of tools, that is Trivy, OWASP and SonarQube. These three tools are used for code quality, vulnerability scanning and dependency checking. I will show you the results and how I perform these scans and how I manage to reach 99% of the code quality and 99% reduction of vulnerabilities in my code and in my image, that is Docker image. But first, let's understand the importance of code quality and vulnerability scanning and dependency checking. We must know that whenever we prepare our application or whenever we build our application from scratch, for example, you have your application in your device, in your folders. You haven't put that application on your GitHub yet, but that application is in your device, in your folders, and you are running it locally and it is running perfectly fine. However, that's what you think, that the application is running fine, but there are specific standards, compliances that find the application security, its vulnerabilities and its security in short. So these tools help us find these vulnerabilities and they guide us to fix them. The application is industry ready, or in short production ready, so it doesn't have vulnerabilities and it is safest and it is the cleanest software that you can produce. So before I did all these scans, I thought my application is really good and it wouldn't be having many vulnerabilities and anything like that. However, when I performed these scans, I was really shocked. I didn't observe I would be having these much vulnerabilities, this much code smell, bugs, etc. So my application was working really fine and it was really good. But however, after I performed this scan, lot of vulnerabilities, code smell and all these bugs, and I managed to fix all these errors, bugs, vulnerabilities, and reached the point of 99% increase in the code quality and 99% reduction of these vulnerabilities and all these errors. I'll guide you through all this process step by step with each tool to watch this video completely. So let's begin. First, just understand my approach, how I operated in dealing with the code quality, vulnerability scanning, all this. First, my aim was to scan my source code or my file system. So the best way to do that was by Trivy Filesystem scan or simply scanning my application raw. So the command I implemented was docker run rm-v, the file path of my application with /app space aquasec /trivy and its version space file system, that is short form space fs space hyphen include dependencies space /app. This was the command I implemented. It runs a Docker container, which would be for the Trivy scan, and this would scan your application, source code, and developer dependencies. So this was my initial scan. I performed this command and it was detect vulnerability. So after my first scan, I got the results that was 1 low vulnerability, 11 medium, 17 high, and 1 critical vulnerabilities. So I fixed all those vulnerabilities by replacing the packages and installing the right packages, and I performed the scan again to see how many vulnerabilities I would be having after that scan. After doing the second scan, the vulnerabilities were significantly reduced and it was only 2 medium vulnerabilities and 2 high vulnerabilities left. But I wasn't satisfied, so I fixed all these 4 vulnerabilities and tried to scan again, and it was 0 vulnerabilities after that scan. So that was my initial approach to scan my application and its dependencies in the source code or in the application itself without running it, without building image or without running it in short. I just perform this command to scan the application source code, application dependencies or application developer dependencies. So this was my first approach and successfully managed to reach the 0 vulnerabilities in here. So you can say it is 100% reduction of vulnerabilities from this scan and 100% increase in the code quality from this scan. But it wasn't the case. In my second scan, I had to perform OWASP Dependency-Check, which simply means OWASP checks the dependencies your application runs on, and it checks the dependency your application runs on. Is it safe? Is it vulnerable or not? So I tried to scan the OWASP dependency too. I'll guide you through how I did. So first you would have to go to the nvd.nist.gov to request your API key. So NIST simply is National Vulnerability Database, NVD. So I had put my name in the organization name and my email, and organization type was personal use. So I submitted that. After submitting, I got the email providing me with a unique ID for trying to log in to my account. I tried logging in with the unique ID which was given by NIST NVD website for the login purpose, and after doing it, it showed me to generate the API key. I generated it. That was the first step in the OWASP procedure to get the API key. After generating the API key, I updated my Docker Compose file by adding isolated security scan for OWASP, which did not affect the Docker Compose when I ran that for building the image. So this was an isolated scan just for OWASP, which would not run when I would build the image. So I would only do this to run the dependency check by doing Docker Compose. So I added this isolated security scan service in my Docker Compose file, which was something like dependency check, and the image was OWASP dependency check, profiles, tools, volumes, that is SRC, ODC data, USR share dependency check data. Environment was NVD API key, which is the API key I generated by doing the login purpose, which I shared before. And the command was scan/src. Format was HTML report, and output was src/report. In this folder, I would get the report of my scan. And again, NVD API key, which I generated. Exclude was node modules, and exclude was DB data. That was a Docker Compose file just to run this dependency check isolated without affecting the Docker Compose build. So after doing that Compose file thing, and I performed the command that was Docker Compose run --rm space dependency -check, and I ran that command. The scan was successful, and I got my report in the reports folder, and it was named dependency check report.html. It was an HTML file, as we stated that in the Docker Compose of our dependency scan. I checked the dependency report, and it had only one dependency vulnerability, which was critical. So I had to fix that vulnerability. So I quickly updated my package.json with the required dependency that wasn't vulnerable, and I ran the scan again. After my second scan, it was zero dependency check vulnerabilities. So my application was 100% safe in the sense of dependencies. So 100% fix for the dependency and 100% reduction in the dependency vulnerability. So that was about OWASP dependency vulnerability fix. Now third was SonarQube. SonarQube is a open source tool, software, whatever. This is to scan your application's code quality, your application's bugs, your application's ability to run. So in short, it checks if your application is even capable of running. So it provides you with the results that would hint you or guide you to make your application better. So it is safe from vulnerabilities, and it is secure, and it is up to the mark of the security. So to perform the SonarQube scan, the first step was to run the Docker container. The command is docker run space -d --name space SonarQube /-p port 9000 map port 9000 /SonarQube LTS, and I ran that container. Second command is docker start SonarQube. So it would start that container. After performing that at port 9000, SonarQube would be available at it. So I logged into the local host 9000, and I was redirected towards the login to the SonarQube. So the first step on this interface is to give a login ID, that is admin, and the login password, that is admin. So both has admin and login and the password. After doing this, I was redirected to update the password. I added the old password admin, and I created a new password, and I updated it, and I logged in to the SonarQube interface or SonarQube dashboard. After the successful login, scroll down and create the project. I name the project, that is Resume Matcher, and I set up that project. After setting up the project, now it's time to generate the token. So I head back to the security section in the SonarQube, and I generated a token for my project. I named that is Resume Matcher, and the type was project analysis token, and the project was the project that I created, and I expired that for 30 days and generated the token. After the token was generated, I had to create a Sonar project.properties file. This was a properties file, that is .property. So inside this file, I named the project, that is Resume Matcher, and the host URL, that was localhost 9000. Sonar login with the token that I generated. So Sonar sources was to let SonarQube know which folders to scan for my application logic. And this was simply the file that would run and that would provide us the results for our scan. So after creating this Sonar project properties file, I log into my CMD terminal and switch to the project folder of mine and perform the command that is sonar-scanner, and it began scanning. And after the scan was completed, I head back to the localhost 9000, which was the dashboard of the SonarQube, and it showed passed on the quality gate check, and it showed 2 vulnerabilities, 7 code smells, and 10 security hotspots. So one of them was related to the API keys and making sure it is not closed or it is in a secret or is not easily accessible if hacker tries to access it. And it has all these complexity, vulnerabilities, and code smells. In short, it was 6 denial of service, 2 permissions, 1 cryptography, 1 others in the medium. So these all were the results of my initial scan, and it showed a lot of vulnerabilities and code smells and security hotspots. So the first step was to fix these vulnerabilities. I tried fixing the other vulnerabilities with the logic and code quality or the code logic, reducing the complexity and all this that was within the files of my code, and I fixed all this. However, in the sense of the Google API keys and making it private, my approach was to create a Kubernetes secret file, keep those API keys as a secret. To do that, I had to create a Kubernetes pod. So my approach was to first log in into my Docker by performing Docker login, and I pushed the image I built of my application. After pushing, I performed kubectl get pods, and the pod was running. I created a Google CXID secret YAML file, and I applied that by kubectl apply -f and the file name .yaml, and the secret was created. And I updated my deployment.yaml and performed kubectl apply to configure that secret. After performing and creating a secret and keeping my API keys in a secret file was a game changer, and that vulnerability was removed or fixed. Now next was to improve the quality gates. Initially the image you are seeing, it shows pass, but after I performed a few scans for fixing the code or fixing the vulnerability of the Google API key, the quality gate was failed and it was not passed. So to fix that, I had to perform test files, so my application or how to increase the coverage of my application by the SonarQube, and that coverage must be vulnerability free and it must be secure. To do that, I created test files, but first let's understand the initial quality gate and the coverage of mine. As you have seen, it was 0% coverage. It was the initial scan, so it showed pass. But after a few scans, it realized that the code is not covering my application really well, so it showed a quality gate fail. Fix that, I installed Babel Jest. This is the application or software that is used to scan or create a test for the application, and it gives us the report of that test, and it says how much percentage of test is complete and how much it rated your application and the test of your code. So I did npm install save dev jest babel jest at core, and I performed this command and I installed that package. After installing that, I performed npx save jest space -- clear cache to clear initial cache of previous scans, and I performed again npm test to test my application code. After scanning, it showed very less percentage for the functions and for the lines. In short, we have to create test files or test script for our application code. For example, my application had certain files to extract a resume text and scrape the Google jobs and to scrape the semantic batch. This was my requirements for the backend, you can say, in order to work my application. So in the code quality, my SonarQube was saying that it was not able to judge the quality of that file. So I had to create a test file for all these 3 folders or all these 3 JS files of my application backend that performed the activity. So the test file would be approved to the SonarQube. So it reads the reports from these scans of the Babel test, and it would see that the percentage is now 100% after I fix all these errors in the test files, and all these errors in the exact files of my backend. So initially the test report of the barbell test or testing of my backend code was not that high, and I fixed all this code and it was initially failing a lot. After I fixed my resume text, scrape Google Jobs, all these three to four files, so the coverage would increase, and the coverage that SonarQube would now see must be 100% or even higher than 80%. So fix all this, I created test file and I make sure I would get 100% on these test reports. I was successful, and my final scan showed 100%, 100%, 100% on all this, and it was overall 92.47%, and it was passed. So after that pass report from the barbell test or testing of my code files by creating a test report, I performed the scan. After I fixed the vulnerabilities, hotspots, code smells, now I had passed the quality gate with 33.6% increase in the coverage, and it was 100% of fix in the vulnerabilities, 100% fix in the bugs, 100% hotspot fix, and 100% fix of the code smells, and 33.6% increase in the coverage of my application. So overall, we can say it is approx 100% fix in the SonarQube scan. So that was about SonarQube and scan. The tricky part is to understand the concept of me increasing the coverage to pass the quality gate. Also, one more thing to note is I clicked on the profile of my project inside the SonarQube, and inside the measurement, I changed the format from new code to each scan from one day. So it would just check the previous scan and its improvement from the previous scan to the new code. So the scan would be really fresh and the reports must be accurate. So simply, if you are confused about the test file concept in the coverage or in the code smell in the SonarQube section, you can simply understand it by knowing that SonarQube initially, when it analyzes the code, it checks for the coverage of actual working of your application. That is, there must be certain files that you have created that does the job of giving you the purpose of the application. For example, my application is used to scan the resume and provide the results with respect to your resume. Provide results in the sense of job results or in the job posting. So the purpose is to scan the resume, extract the keywords, etc. So the initial scan results of the SonarQube, that is the results that I got, which was vulnerabilities, code smells, and network hotspots, security hotspot, etc. That means SonarQube analyzed my application and its code, its working, everything, and it found certain vulnerabilities, code smells, and security hotspots. So that part of my application had error or vulnerabilities or whatever you can say. The rest of the application was fine and it was passed by SonarQube on its standards. That's why in my first scan, it gave me security gates that was passed, as it didn't cover anything other than giving me the vulnerabilities and code smells, all these errors. So after I did the second scan, fixing some vulnerabilities and code smell, the security gate turned failed, because while I fixed those code smells and these vulnerabilities, I did not fix or I did not fulfill the quality gate standards. That is, the quality gate standards, your code must pass the test of 80% or more. That test simply is the working of your code. For example, my application had certain JS files that serve the purpose of extracting keywords, extracting the resume, scraping Google Jobs, etc. These three to four files were serving the purpose, and there were many other files as well. But these 3 to 4 files also showed error in my SonarQube results or in the scan. So SonarQube said, like, simply you fix these code smells, vulnerabilities, that's good. But have you fulfilled the criteria of security gate by making your code that had the vulnerabilities to make it pass the quality gate check, that is the test of your code, by 80% or more? So that's why after I fixed all these vulnerabilities, the only thing that was left was the quality gate standards. So I fixed all these vulnerabilities, security hotspots, and code smells. I knew that I had certain files that I fixed during these and all these security hotspots, code smell. So I created .test of all these files that were like 3 to 4 files, and I performed the barbell jest test, which I explained prior. After my initial test results of those test files of the vulnerable files that were fixed, that test results were not up to the mark. It was 60%, which was not the standard. It must be 80% or more to pass the security gate standard of the SonarQube. So my aim was to at least reach the 100% mark, so I don't have anything to worry about, like the security gate. So I made sure the test results reached 100% in the results PM test. So I fixed the test files. I fix the files that had vulnerabilities, and I reached the 94% of overall test results that were passed of those files, which was initially scanned by SonarQube as code smells, vulnerabilities, etc. And that also passed the quality gate standard of at least 80% or more, which was 94% increase or 94%. So that was a reason in my last scan, it was 33% coverage. With that 33% coverage passed the standard of 80% of more quality code. I hope it makes sense. Like the 30% had the issue of vulnerabilities, etc. And I fixed those vulnerabilities first. But SonarQube said like, yeah, you fixed those vulnerabilities, but the code did not pass the test. The test simply is the unit testing. In the software development, there is a concept of unit testing, testing the working of your code. So the test must pass the at least 80% of it, of each code, each file of your application that showed the vulnerability. So after I fixed those by reaching the overall file standard of 94%, the security gate also was passed. If you have any doubts in this, you can let me know in the comments section. I will try to explain it further as well. So that was about SonarQube. So until now, we have covered Trivy, OWASP, and SonarQube. And after doing all these three tools, methodologies to scan the code, vulnerability, dependency check, etc., I was really confident that my code is really good, really secure, really vulnerable free. But that was not the case. The last part, the final part, was still left, which was scanning my application's image by creating a Docker file and creating an image from it. So my thought process was like, application has passed the Trivy vulnerability with 100%. My application code and everything has passed the OWASP dependency check, and I have fixed that. I have also fixed the SonarQube code smell, security hotspots, and vulnerabilities of it, and also the important part of security gates, which was passed. So I was really confident that yeah, my code is really secure, and even if I scan the image after building it, there wouldn't be any vulnerabilities as such. But I was completely baffled and overwhelmed after I saw the results of the image I scanned. Before diving into it, I'll just explain the process. Start what was my thought process in doing the image scan and how I did it successfully. So our goal is first to scan our code, which we did, and we scanned everything from the SonarQube, OWASP, and Trivy, which is really good. But here comes the tricky part. The real application in DevOps or in a secure environment is the image. The image is really important aspect of our software development journey, because the image containerized application is what we take over in our later process of Kubernetes, pods, and later deploying that application. So image scanning is really purposeful aspect of this process. So first, I created a image scan.sh, which is a shell script to automate this image scan process. So I'll just explore you through the image scan.sh code script. First is set equals -e, which is used to exit the code immediately if a command exits or if there is an error in a single command with non-zero status. So then there is configuration part, the important part. Image name equals resume matcher DevOps web latest. raw_json equals raw scan.json. Final report equals scan results.json. So scan results.json is the final report I would be seeing to understand the vulnerabilities in the image of the containerized application. First command was docker system prune -a-f, which is to completely delete the Docker system information that was like deleting the prior Docker images, containers, networks, everything in the Docker containers. So my aim was to manage the storage of my Docker and my system. So by doing such command, I would be deleting or clearing all the residue, all the junk of the previous Docker images which I was not using. So this command helped me clear all the previous data of the Docker which I was not using. And next command is remove, that is rm space f raw json final report. So the purpose of this command was to delete the previous scan results so the new report is clean of the prior results. So this command would remove the previous scan result, which was raw scan JSON, scan results.json. So the new report is clean. And second part of the script is resetting the node environment and cache, which is removing rm/rf node modules package log.json. So this command would remove the node modules package log.json, and the next command is npm cache clean base -hyphen force. So these both command is used to delete the node modules and package log.json and clearing all the cache related to it. The purpose, I wanted to have a clean node modules each time I run the script. So I would be updating the package.json in my application. I would be updating the package versions, etc. in order to fix the vulnerabilities. So after each update of the package.json, I had to remove the prior node modules and install the node modules again. So the new node modules would have the updated package.json and its versions. So this command would remove the previous node modules and package log.json, which didn't have the updated package.json, which I have updated. The next command is npm install. So this is the next part of the previous command, which simply means like after I remove the node modules and package log.json and clear all its data, so new package log.json must be created and new node modules must be created with respect to the updated package.json, which I would be updating. So after deleting the node modules and package log.json, npm install would install a new fresh node module and new fresh package log.json, which would be updated with respect to the updated package.json, which I was updating. And next command is npm audit fix pipe true, npm audit fix force pipe true. So these both commands are to fix some errors or vulnerabilities if npm install wouldn't fix that. For example, if I would be performing npm install and it would say some packages are not installed or some packages need to be fixed, would fix any issues in the node modules and package log.json if it had any while performing an install. So npm audit fix and npm audit fix force would fix any issues if it caused by npm install. So purpose of this three command is to install fresh packages without any vulnerabilities. And fourth is docker compose build no cache full. This is really important step. So while prior command were to clear all the prior data of the system, Docker system, that was including images, containers, networks, all the data, all the containers, etc. and clearing the node modules, clearing the package log.json, clearing the cache of it, and installing the fresh npm install with npm audit fix or fixing the prior npm install error if it caused any. So that was really important step which we did. So now comes the important part of building those new packages which we installed after updating the package.json. So this Docker Compose built the image without any cache of previous results and it would pull the latest image. After doing that, image would be built with the name resume match your DevOps web latest. So all these commands lead us to building the image without any cache and pulling the latest image. So the next command is Trivy clean all. This command is to clear every data of the prior Trivy scan. Simply, we are clearing all the information, all the scan data of our previous scan. So the new scan is a fresh without any manipulation of its data of previous scans. So we are clearing all the data of previous Trivy scans. Now, next is generating the raw JSON data. Now we are doing the actual part of scanning the image with using Trivy. The command is Trivy Image. I only wanted to fix the issues that had the severity of high and critical. So I had given statement severity, high, critical, and to give me that information in the format of JSON, and the output would be raw JSON, which I have provided the previous name and image name, that is resume match and DevOps latest. So sixth is filtering results into the final report. So the command is node-e. So simply the aim of this code, which you are seeing in the stick format, is until 6, it would create a raw JSON file that would have all the information of the vulnerabilities, scan results, etc. That is great. Like raw JSON is also a great vulnerability report. If you would be doing until 5th of the echo statement, you would get the results of the image scan, etc., which would be perfectly fine. However, I wanted the raw JSON data to be filtered out in the format of title of the vulnerability, description of the vulnerability, severity of the vulnerability, TWE of the vulnerability, primary URL of that vulnerability. So my aim was to get the scan results in these 5 lines of each vulnerability, and I would discard all the information prior or other that is inside the report of raw JSON. I hope you got my point. So until 5, you would get a report of the JSON file with all the vulnerabilities and more information related to it, which I did not want. I wanted only the information that was title, description, severity, CWE primary URL of the vulnerability, so I could fix it. So the 6th echo statement does the same. It takes the raw JSON file which was created till 5, and it would filter out the information and give me the final report that would have title of the vulnerability, description of the vulnerability, severity of the vulnerability, CWIDs, primary URL of the vulnerability. That is the only information I need of the vulnerabilities. If I would not do that command, I would be getting a big JSON file of the raw JSON, and I would have to scroll down, perform the control F and search for the keyword high, find the vulnerability between it. I simply wanted to automate it. So in a simple JSON file, so I created this 6th part of the JSON file. If I would not do this 6th step, I would be getting a raw JSON file which would have all the information, including title, description, severity, CWIDs, primary URL, and it would have more information which was not required to me. Although it could be required for someone, but I did not need it to fix the vulnerability. I only needed title, description, severity, CWIDs, and primary URL of the vulnerability which I would be getting after the scan. So yeah, after this command, it is echo pipeline ended, pipeline completed successfully. So that was about the shell script I created to scan the Docker image. After this, I perform chmod space x plus image scan.sh to give executing permissions to image scan.sh. So chmod would give permissions for execution of this shell script. So after this, I ran the shell script by // and the shell script name, that is image scan.sh, and it started executing it. First, it gave the output environment cleanup, and it cleared or cleaned the prior containers. It deleted containers, it deleted images, it deleted build cache objects, and total space that I reclaimed was 4.53 GB, which is really good. And the second command of ours in the shell script was resetting local node environment and installing the packages. So it installed by doing npm install, and it performed npm audit, and it also performed npm audit force. So that's why you are seeing the force statement in it. And it installed the packages and everything, and it said found 0 vulnerabilities while installing the packages by doing npm install, npm audit fix force. And now comes the 4th part of building the Docker image. So this information is of building the Docker image, and Docker image successfully built. Its name is Resume Matcher DevOps Web, and our 6th, that is filtering results into scan results.json, and successfully filter 22 vulnerabilities. So that was the result of our shell script. After I ran that shell script, scan, create the packages, to delete the prior Docker residue, to delete the prior node modules, and create fresh npm installs, build the image, scan the image, and create the scan results.json, which would have only the filtered information which I wanted, and it successfully filtered 22 vulnerabilities, which is really, really high. So as I said before, I was expecting after doing Trivy, OWASP, and SonarQube, I wouldn't get any errors, any vulnerabilities. I did all of this, but still I got 22 vulnerabilities while scanning the image. So it shows us the importance of scanning the images and performing scans of each aspect of our code, so it doesn't have vulnerabilities and all these bugs. So after seeing 22 vulnerabilities in my results.json, I tried fixing it by updating my prior Docker file. I hope you remember I had a Docker file actually I have created before, but to fix these issues, I had to update my Docker file completely. So I had created and updated the Docker file. The first statement is node 20 bookworm slim as builder. So this was the Docker file I created. It has 4 stages in it, and I wanted it to be distroless, so the image would be small. So I created this updated Docker file so it wouldn't have vulnerabilities in my later scans. And the Docker file you are seeing is the final Docker file that doesn't have any vulnerabilities in it. The next scan result you are seeing is after doing the vulnerability fix by updating the packages in the package.json. I updated the package versions to the versions that were required that didn't have any vulnerabilities. After doing all of this, scan results showed only one vulnerability, which is really good. Like I managed to tackle 21 vulnerabilities of image scanning. A single vulnerability was not of that severity. So that is the scan results.json. As I mentioned before, I wanted the clean output so I could be fixing the vulnerability easily. So the scan results.json you are seeing is the output I would see in the scan results.json, which is like title of the vulnerability, description of the vulnerability, severity of the vulnerability, CWE IDs of the vulnerability, primary URL of the vulnerability. And after fixing the Docker image and getting only single vulnerability, which was manageable, which is not of a big deal, I managed to clean the image by 99%. It was only 1% of it. So I finally did Docker Composer to run that image. As you can see, the image is running on the port 3000. So I switched into the local host 3000 and uploaded my resume, and it showed me the result, and it was working really fine and really well. You can also see in this logs that the application and the image is running beautifully. It is showing the logs by showing the results of the front end as well. After successfully running the image and it showing me the results and my application was working fine, so I finally pushed Docker image, which was only having single vulnerability, which was manageable. I finally decided to push this image into Docker Hub. So I performed Docker login. I tagged the Docker image with respect to my Docker desktop ID, and I tagged the Docker image and I pushed the Docker image into it. Now, as you can see in the Docker Hub, the image is successfully pushed into it. So that is it for the video today. I hope the topic was simple and insightful. It is a long video, but it was really important to explain and show how image scan, how code scan, vulnerability scan, dependency scan in a file, in a code of the applications work, and how fixing the vulnerabilities reduces it and giving us the results of clean, bug-free, error-free, vulnerable-free application, which is a standard of today's software development. Thanks so much for watching. Have a great day.